Continuing from our last video, we're going to do an example using the IVT. So the velocity of a particle moves horizontally along the x-axis, and it's given by this continuous function. That's important, right? We're going to explain why there must be some time where the particle changes direction. So we have to talk about something being continuous. Okay? The particle travels continuously. We should mention that. Come on. All right, continuously. And we're talking about is pretty, and that's actually on all real numbers, but we're looking at selected values. This is the hard part for people. We know that if it was traveling at a negative velocity and then traveling at a positive velocity, somewhere it had to change direction, and that's when the velocity is zero. Now, wording this can be kind of tough, and you're going to figure out your own way that works. You just have to make sure you get all of the right information here. All right. So we could say since the velocity at 0 is less than 0, and the velocity at 8 is greater than 0, there must exist some time, you could pick any letter, let's just say T, on 0 to 8, such that equals 0, and that's by the IVT. All right, so I know I wrote a lot there, but let's break it down. So first, we're proving the hypothesis of the IVT. We said it's continuous on a closed interval. Then we're using this idea, okay? We're using all of this here. And what we're saying is since this is less than 0, this is more than 0, sometimes since it's traveling continuously, it must pass through 0 by the IVT. All right, show that there's a positive real solution to this equation. So let's say let f of x, let's just move everything to one side, equal x to the 5th minus x minus 2. Okay, f of x is continuous since defined by no function for all x values, all real x values. Let's see. We need a positive real solution, so that means I need x to equal 0 somewhere. So just pick some values and plug in. I can pick one's a good number to plug in. 1 minus 1 minus 2. Let's see if I plug in 2. 2 to the 5th, so 32 minus, sorry, 28. Oh, good, I picked a good set of numbers. So, since f1 is less than 0, and f of 2 is greater than 0, must exist some, let's say C, on 1 to 2, such that f of C equals 0. Okay, and then that would imply that this equals this by the IVT. All right, again, it can be kind of confusing You work on wording. As long as you say that there's opposing values, you say that there's some thing in that open interval where it equals whatever you're looking for. By the IVT, you should be pretty good. Let me try this one for the list. And we'll talk about it in class. And then here we have example 10. This is a modified part from the 2007 AP exam, which I took and passed with flying colors. All right. So here we have f and g. They're continuous for all the numbers. That's good. And each of x is a combination of those. So explain why there must be a value of r on 1 to 3, such that h of r is this. It doesn't say use the IVT. It just tells you this information. So you have to think back at the end of the year. You have to think back to this and say, oh yeah, the IVT. So first, we need to satisfy the hypothesis. H of x is continuous. For all the numbers, because f and g are continuous for all the numbers. Plot that out further. We're testing on this interval, so we're going to find h of 1, which is f of g of 1 minus 6. That is, let's see, g of 1 is 2. F of 2 is 9. So it looks like that's 3. Okay, we'll test the other down. H of 3. F of g of 3 minus 6. G of 3. 4 minus 6. Negative 1 minus 6 equals negative 7. All right. So we're trying to prove that h of r has to equal negative 5 sometime. And it will, because negative 5 is between negative 7 and 3. All right. Let's say since negative 5 is in between negative 7 and 3. Okay. Or f of 4 is less than negative 5. And negative 5 is less than f of 2. I'm going to change this notation here. There exists some r of that interval such that h of r equals negative 5 by the IVT. And there you go. So that's the end of this section. Hopefully it's not too confusing. Practice with this, and I know you'll get better.